probability. Still looking at our probability stuff. Some of this, the independent, y'all listening? The independent, the dependent, and the, oh, what was that other one called? Conditional. Those that we did last week, the word and was involved in lots of them. But now today we're going to start looking at some that's got the word or involved. Like, could I be in this one or that one? And so you've got some new terms that, and the ones that I bring up there on the board are a couple of them, disjointed and overlapping. Disjointed, a lot of times, another word that you'll see that means the same thing instead of disjointed is mutually exclusive. Okay? Mutually exclusive to me makes more sense in my brain, but they use both words, so we've got to be familiar with both of them. But it just means that it's only in one of them. Like if I'm saying it's in this one or that one, it's not in both. It's in one or the other. It's mutually exclusive. Mutually, that puts by myself in my brain, and so I start thinking about by myself then.
Jared Rapp, please come to the school office to check out.
Now, the formula that we're going to use for that, if something is disjointed or mutually exclusive, it's going to say the probability of A or B is equal to just the probability of A plus the probability of B. Now, do you see the major difference between this formula and the one that had and in it last week? Very good. This one with or, we're adding. Last week when it was and, we multiplied. Remember that? Okay, now if it's not disjointed or mutually exclusive, that means it can be in both scenarios. So that's what I've got up there for your overlapping. The formula for that, if they're overlapping, or if it's not mutually exclusive, the probability of A or B starts off the same. Take the probability of the first one, add it to the probability of the second one, but then you got to subtract out the probability of both of them. Because if it's in both of them, if you think of a Venn diagram, and I am going to look at some Venn diagrams in a minute, if it's in both of them, you can't count it in the A one and in the overlapping one. You've got to subtract it out in there. You don't get to count it twice. All right, everybody got your formulas ready to look at a couple? It's a very difficult scenario today. Alright, it says here we got a card is randomly selected from a standard deck of 52 playing cards. What's the probability that we randomly select a 10 or a face card? Alright, so I've got 52 cards, a 10. I'm going to Venn diagram us on this. I could have a 10 of hearts, a 10 of diamonds, a 10 of spades, and a 10 of clubs. Is that what the four suits are? Okay. Now, are 10s, are any of those face cards? Do you know about a deck of cards? Do we need to review a deck of cards? Y'all played solitaire before, know about a deck of cards? Alright, so face cards that I have are anything Jack, Queen, King. What about Ace? Is an Ace considered a face card?
Doesn't have a face.
Alright, you're exactly right. That's good logic there. And I could have all three of those for all four suits, right? So that actually means there that we've got a Jack of Hearts, a Queen of Hearts, a King of Hearts, a Jack of Diamonds, a Queen of Diamonds, a King of Diamonds, a Jack of Spades, a Queen of Spades, a King of Spades, Jack of Clubs, Queen of Clubs, and a King of Clubs. Alright, so I'm looking for the probability of a 10 or a face card. So can I be in both of these circles? Can a 10 also be a face card? No. Can a face card also be a 10? No. So this is the disjointed. It's the mutually exclusive. It's the disjointed. So all we have to do on this is find the probability of the first one. So what's the probability that I'm a 10? Well, I got 1, 2, 3, 4 of them, right? out of how many cards are in a standard deck? 52. Okay, you could reduce that to 1 out of 13 if you want to. Alright, what's the probability that I'm a face card? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 52. Right? What did my formula say that I needed to do with these? Add them. So I got 4 out of 52 plus 12 out of 52. Should be 16 out of 52. That is the same if I reduce that, divide them up by 4 as 4/13. I like that number, but you can put it as a percentage if you want to. It'd be almost 31%, wouldn't it?
So like at the beginning of the problem it has B, A, or B. So like it doesn't matter what you have in that place.
In what place?
Right here.
That's the 10 or the face card. So this would be your 10 would be your A, your face card would be your B. Okay, pretty simple to do on that, not too difficult. Let's look at another one.
Hey, can I work these on?
Well, get on the stick. Yep. Alright, this next one that we got here, still going to be using the standard deck of 52 cards. Somebody says a card is randomly selected from a standard deck of 52 playing cards. What's the probability that our card is a face card or a spade? Alright, so what I got to think about when I start, I'm going to draw some Venn diagrams again on this. Can this be overlapping? Can I be a face card and a spade? Yes. So I'm going to have an area where they overlap. Okay, if I am a face card and a spade both, I'm going to be in that overlapping section right there. Okay, so just my face cards to start with. Got a jack, a queen, a king, and all 4 suits. Okay, we'll say there's my hearts, my diamonds, and my clubs. But my spades are going to be in here because they're both, right? Jack, a queen, and a king spades. So here's face cards, here's spades. Now, what other cards do I have that are spades? A 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10. And an ace. I've already listed the jack, the queen, and the king, right? Alright, so our formula now when we're overlapping says we have to find the probability of the face card plus the probability of the spade minus the probability of both. And I'm just going to put A and B since I ran out of room. Alright, so the probability of my face card. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Probability of spade. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Everybody okay? Minus probability of both. So how many are in my overlapping area? 1, 2, 3. So 13 is 25. 25 minus 3 is 22. So we're looking at 22 over 52, which is 11 out of 26, which would be about 42%. And I talked to you a little bit last week about how you write your answers. I don't, fraction, decimal, percentage, as long as you're not told how to write your answer. I didn't specifically tell you on this one. As long as you're not told, you can write it whichever way you prefer. I think it's pretty obvious to y'all that I prefer fractions or percentages. That's the way I do mine the most. But you need to make sure you read the directions. If it specifies, give your answer to as a percentage or as a fraction, do what they tell you. Okay, but if they don't and you like fractions best, that saved you work. You didn't have to go type it in your calculator. You could stop at the fraction. A lot of y'all on that assignment that y'all did on Friday put percentages. That's cool. Percentages mean more in our brain because we work with those more in like shopping situations and all that kind of stuff. So doesn't matter to me. Okay, why did we subtract on that one? Because we had some that were overlapping, some that were in both. It was not mutually exclusive. You could be a face card or a spade at the same time. Alright, pretty simple stuff. This next one that we're going to look at gives us all the info, and we have to use the formula to work backwards. You had a couple like that on your assignment on Friday. It gave you like the final answer, and you had to work backwards to find one of the parts. So we're going to do that with this stuff right here now. It says, out of 200 students in a senior class, so I want to hold on to that number, out of 200 students in a senior class, 113 students are either varsity athletes or on the honor roll. So if I set this up, this would be varsity athletes or on the honor roll, and that was 113. So look what that's already the final answer that I have there, isn't it? Okay, then we'll keep reading here. There are 74 seniors who are varsity athletes. So the probability that a varsity athlete, I got 74 seniors. 51 who are on honor roll. Okay, so they've given me all that stuff, but now the question says, what's the probability that a randomly selected senior is on both? So, overlapping. So your overlapping formula says probability of A or B, you just got this on your paper so you can see it, is equal to probability of A plus probability of B minus probability of both. Okay, so we can fill all this stuff in now. Our A or B is the 113 over 200. A, 74 over 200. B, 51 over 200. Minus, this is the part I don't know. And you can rewrite all that again with the, you can put it as, I'll just bring it down. I was thinking I might just put a variable in there, but I'll just bring it down like it is. Okay, so we're trying to solve for that unknown. It looks mean and ugly because you've got fractions, but first combine your like terms here. So it'll be 113 over 200 is equal to 125 over 200. Is that right? Five, 4 and 1, 7 and 5, yeah. 125 over 200. And then minus probability of A and B. Alright, so this is, if this bothers you, remember over here where my mouse is, the probability of A and B, that's just like your unknown. That's a big X. So you can just put an X in there if you want to. We're trying to solve for this, so we need to get it all by itself. Lots of times here, I would subtract the 125 over 200. It doesn't matter. You can decide what you want to do first if you want to do that, or if you like to keep this positive, so you want to move that over and then subtract. It doesn't matter. So what do you want to do here? Okay, subtract the 125 over 200. So that's going to get you a negative to negative 12 over 200. Is that right? Is equal to negative probability of A and B. Okay. Now this is like a negative X, and this is negative. So what would I do to solve for the positive? Divide by negative 1. So that's the same as just changing all the signs. So 12 over 200 is equal to the probability of A and B. That's what we were looking for. How many people were varsity athletes and on the honor roll? Normally we reduce fractions, and we'll probably have to reduce this one, but in context of the problem, that's the best answer. Because we were talking about out of 200 people. So out of those 200 people, I know that there were exactly 12 of them that were a varsity athlete and on the honor roll. So I actually like that 12 out of 200, but let's go ahead and reduce it. It'll be 3 out of 50, which will be only 6%. Now that 6% is a pretty useful number. That's telling me that I don't have very many smart athletes.
Yeah, that's a low percentage.
Yep. Well, 12 out of 200 is a low number.
Yeah.
Alright, pretty simple, easy stuff on that. Any problems or questions on that? Tomorrow's stuff, we're going to talk about some funny words, permutations and combinations. Those are the kinds of questions when they ask, like, there are 7 people trying out for the defensive line on the football team, and how many different orders can how many different ways can those 7 people be arranged? So it's talking about number of arrangements like that. There are some formulas, but even better, there's some buttons on the calculator that do permutations and combinations. So when we go over those tomorrow, I'll show you the formulas, and I'll show you how to do it in your calculator, and you can do it either way. But you always see those types of questions, and how many different ways can those 4 students be arranged? You know, and you're trying to like visualize moving them all around, but there's actually some formulas and buttons to push to do that. So it saves you some time.
Carson Smart, please come to the law school office to check out.
You went a bunch of like practice activities, fires in it, and there was like a bunch of those.
Yeah. All right.
They're not a lot. But they're like different ways you can arrange stuff.
There you go. Is that?
Oh, can you look on that right now?
Yeah, you can finish it if you want to.
Yeah.